So let's try to understand this question here. We've got to draw, well, we had to label the North and South poles. This is correctly labeled. Let's just take these off for a moment. So how would I know which way is which? And also, how can I complete the field lines? Well, first of all, we're going to look at these pictures up here. So what we're seeing is that a north and a south would attract themselves to each other. A north and a north would repel each other, and a south would repel. So those are some key words there, by the way. So I will just label them. So attract. In fact, I'll put the full. No, I will. I'll just write the word first. So let's just make that a bit smaller. So the word there is attract, which most people know, and this is repel, and this is also repel. So the sentence that is we want to write about this is that we say opposite poles. So the north and south, they're poles, attract. Okay, that's the first thing. So that can go up at the top for this one here, and then, well, actually, opposite poles attract, and then these ones we don't say identical like you'd imagine, but we say like poles. And obviously they don't attract, they repel. So the reason we say like is because one could be a stronger North Pole than the other. And so it's not identical to it, but it is like it, right? So it's that use of the word like. This is like that, okay? And so we learn that magnets repel, that like poles repel and opposite poles attract. So that's the first. That's something we just need to remind ourselves of, if you didn't know already. So I'm going to move this. I'm going to group that, and let's put it just above the question for now. Now, so these arrows, when we draw field lines, we draw arrows, and basically the arrow is the direction a north pole would move. Imagine we could have a magnet with only one pole, right? And that pole would be north. So I'm going to write an N there and make it red. So it's like part of that magnet up there. If I put it over here, and what the arrow is saying is that it's going to go away from it. Well, why would it be going away? It would be going away if that was north. So that's how we know that must be a North Pole. And if that's the North Pole, then this must be the South Pole. So this is how to do the first part of the question. The arrow tells us the direction of the field lines. That means the direction a North Pole would move. And so that tells us that must be North Pole. Another way you can just remember it is the arrows always go away from the north and towards the south. Okay, whichever way helps you to remember it. So now the next thing to do is to try to imagine what might happen if it was placed at different points. Well, if it was placed here, it's just going to kind of like veer away in this direction, right? I hope we can see these different directions. Now, it's surprising that why would it do this? Why would it do this? Because it's trying to get down to the South Pole. So we're going to have an arrow moving towards the South Pole for a start. These field lines are kind of showing where the North Pole would move at various points. So, what colour is this? Let's make this black and make it a bit thinner. So we can carry on with these field lines, and it's going to be symmetrical. I probably won't do it that well, but you don't need to do it that well either. So how would we draw these arrows? Well, again, it's going to be going away from the north and towards the south, which means up here, let's do that one as well. We want to do an arrow there as well. I think you can probably get away with just doing one arrow on the line. And the same down below. We've got to make it symmetrical. Again, towards the south and away from the north. And it tells you to include the arrow, but what they might do in some questions is just say complete the diagram, and then you need to know that it includes arrows. Okay. Let's just look at C as well, because I think this might be a topic that you've not been taught, so I'll help you with this one too. Describe how you carry out a test to find out whether another bar of a similar size to the bar magnet is a magnet or bar magnet or not. So in other words, what it's saying is if I had another bar of like a metal bar, how can I tell to see if this is a magnet or not? So some people might say, oh, well, if it's attracted to the magnet, then it's a magnet. Not necessarily. It could just be a piece of metal. In fact, well, it's actually not just a piece of metal, but it could be, it would have to be a magnetic metal. So copper or aluminium wouldn't be attracted to it. But iron, cobalt, or nickel could be attracted to it. So in other words, if I put it here and it's attracted to it, then it could just be a block of iron, cobalt, or nickel. So how would I know whether or not it's a magnet? Well, a magnet, as we just said, is attracted and repelled. Really, the only thing that would repel from a magnet is another magnet. So if I find that it's attracted to this one, what I want to do is turn it around and see if it's still attracted. If it's still attracted, I know it's a piece of metal, one of these three metals. But if at one of them it's repelled, then I know that this thing here is a magnet. And not only that, I'd be able to label it. So if it was repelled at this point, I know that that's a north pole and that's a south pole. And if it was attracted, well, again, like I said, I've got to make sure that it is definitely repelled at one point. So yeah, so that's probably what they want you to say there. Check to see if it's repelled from one of the poles. I'm not sure what all the three marks are going to be. Let's have a quick look. Okay, so as you can see in the mark scheme, it's pretty much what I said, but kind of explaining it clearly. So as I said, test to see if it's repelled, and if so, it must be a magnet. If both ends are attracted, it is not a magnet. Okay, if it's not repelled or attracted, then it's also not a magnet, of course. Could just be, it could be just another metal, not a non-magnetic metal. Yeah, so if neither end is attracted nor repelled, it's not magnetic. Okay, so the difference between being magnetic and being a magnet is that it is attracted, like iron, cobalt, or nickel is attracted to it, so that's magnetic. But if it is repelled or attracted, depending on which side, then it is a magnet. Okay, all right.